Hi guys, welcome to my channel Vigyan Jyoti. So the topic is electric potential and potential difference. So we know this word, right? Potential. Potential means something until unless you don't, it's not that when you work done someone is done. When we say you have this potential to do, that means you have not done yet, but we can understand, yes, definitely you can do, right? And definitely you have the potential to do, to excel everything. Okay, now coming to the topic, electric potential, that means we have the here in that case, or you can say with respect to current electricity, what is this potential? Okay, now potential is basically, we will say, as the amount of work. That means if I am saying you have the potential to do this, means you have that ability to do work for particular job, let's say, or particular role. So in that case, electric potential is defined as what? The amount of work. Now in this case, what do you mean by the amount of work? Okay, in this case, what do you mean by the amount of work? Okay, let's see. The amount of work is needed to move a unit positive charge. Okay, unit charge, unit positive charge. Taking this example, it's positive charge. Unit positive charge means 1 coulomb. Okay, 1 coulomb of charge. From where? From a reference point to a specific point against the electric field. So there are various parameters that are coming here. So the first parameter is that we will say electric potential means how much amount of work we can do. Now what is the amount of work? The amount of work to do what? To move a unit positive charge from a reference point. Okay, let's say the point is this A. Okay, so from point A you have started, I am seeing the time, or you can say I am measuring the amount of work done. So what you are doing is you are trying to bring the unit positive, let's say the positive charge was here. You are trying to bring, this is a midway, you are trying to fix this positively, that means positively, or you can say the unit particle, unit charge particle. Okay, now here we have a huge, like not 1 coulomb, more than that. Okay, now we know like charges, they repel first because they are not going to agree on the same point, right? That is the reason my electric field is also going in this direction, your electric field also line coming in this direction. So that's clashing, right? So as a result, we will repel. Okay, now when we try to repel, that means from the system, from when these two were there, they were repelling, right? They will not talk, fine. But now external source, who has that external source? Let's say me. Now I am trying to bring this unit positively charged particle against the will of this particular unit positive charged. So that means I am doing work. Let's say something, you are able to do this work and you will definitely do this work. If I am helping you, means that doesn't mean that definitely I am helping, that is fine, but I am not working on behalf of you. But if you are not trying to do that work, let's say you want to do your homework, but someone else is doing the homework for you, that means that particular work has been done by your friend. That means it's a homework. Okay, so that means in the same way, when we are trying to bring this unit positively charged particle to near this charged particle against the force, against the electrical lines of force of this charged particle, that means I am doing some work, right? And that means this is my electric potential. That means let's say I am doing this work. So when I am trying to, that means this from a reference point, let's say A is the reference point and specific point is B. Okay, the specific point is B. So that means from A to B, I have tried to bring this unit charged particle against whom? Against the electric field. Alright, so this charged particle says don't come, but since I am bringing that charged particle towards this charged particle against the will of both of them, but basically here it's playing dominating more because it has more charge, that means we will say yes, we have done some work. Fine. So before understanding what is electric potential difference, let us know how are these terms or what are the symbols that are used. So first of all, the SI unit of potential is volt, the symbol of potential is V. Now how can we define this 1 volt of charge, or sorry, 1 volt potential? How can we define that? Okay. So 1 volt is a potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb from one point to other. So first of all, a new word, 1 joule of work is done in order to move whom? A charge of 1 coulomb. Okay, that means we will say that if I have done 1 joule of work, okay, let's say, okay, I'll not come like this, I'll do it in a different way. Okay, wait. I'll do it in a different way. Let's say in moving, okay, in moving 3 coulomb of charge, I have taken 15 joules, right? So what did I say? In moving a 3 coulomb charge, I have done how much amount of work? 15 joule. Now electric potential comes into the play and says, I am not interested how much work you have done for 3 coulomb. I am interested how much amount of work you have done for 1 coulomb of charge. So for that case, what will happen? That means if for 3 coulomb, if it's 15 joules are done, that means for 1 coulomb, it will be 15 by 3. That means 5 joules of work will be done. For against whom? Per 1 coulomb. So for each and every coulomb of charge, how much amount of work you are doing? You are doing 5 joules. Excuse me. How much you are doing? You are doing 5 joules amount of work. Now this particular, so this is what is, this is, we can say the potential. This is something that we can say potential. Okay. Now they are saying, what is this 1 volt? This 1 volt is, that means if it has to come for 1 volt, that means how much, that means amount, because this is fixed. This is fixed, that means you have to do the work against 1 coulomb. So if you are doing the work against 1 coulomb and your potential has to come 1 volt, that means definitely there it has to be 1 joule. 1 by 1 will give you 1. So that means if you have used, or you have not used, sorry, if you have done a work of 1 joule against, means you have done this work in moving 1 coulomb of charge, and you have done a work how much? 1 joule. With this kind of position or this kind of state, we will say as 1 volt. That means you have 1 volt potential. 1 volt potential is defined as the amount of work done, that is how much amount of work done? 1 joule. That means 1 joule amount of work has been done in moving a unit positive charged particle from one point to other. So this is the meaning of 1 volt. Understood? So 1 volt is definitely then 1 joule by 1 coulomb. Okay, that is 1 joule by 1 coulomb, that means it's 1 volt. So this is how we can say about electric potential. Now then what comes as potential difference? Okay, now if this is the same scenario that was set up before, okay, now what is happening? Let's say I have tried, let's say means what? I'm trying to move this positively charged particle at point A, and again I am trying to shift it to point B. Okay, so the amount of work that you have done in station A is, that means definitely it's, again I am talking about 1 coulomb of charge. So 1 coulomb of charge, that means I am doing some work in joules. So when I am doing that work in joules and I am bringing it to VA, that means I will say here, that means this much amount of volt of work I have done, right? That means this much amount of work I have done. Okay, so that means VA is how much? VA is equal to the amount of work done in moving unit charged particle, right? That means you have done WA joules in moving a unit charged particle. How much? Unit means 1. Okay. Next, if you try to excuse me, if you are trying to bring this part, okay, chalo, theek hai, it's still VA, means at point VA. Now you are, that means again if that means what you have, now you will bring, now the positively charged particle has come here, now you are going to move it to VB. That means the potential at this point will be VB. Okay, that means how much amount of work it has been done. Now work done at B, again same story, 1, that means this much amount of joules of work we have done in 1 coulomb. Now potential difference is, what is the extra work that you have done from A to B, because in VB your VA value is also included, right? Because after all you are moving the same, you are coming from the same path. That means this is the extra effort which you have done in bringing to A. That means this is the extra potential difference, that means extra work that you have done, because VB also includes VA. That means how much is this? That means we will say this one as VB minus VA. That means work done at B minus work done at A. So since the denominator in both the case is 1 coulomb, that means it's nothing other than the work, the extra work that you have done in moving this unit positively charged particle from point A to B. That's all. So that means this is again you are doing what? This against you are doing it for 1 coulomb of charge. That means we will say this one as potential difference. The answer will be in volts. Why? Because you are already doing it by joule per coulomb. So whenever this joule per coulomb means, we will say that as volts. So potential difference is basically what? How much extra work you have done in bringing this positively charged particle from this point to this point. Did you understand this part? Just the extra work. So potential difference between 2 points, that is A and B, is the work done in moving a unit positive charge from one point to the other. So this is the extra you can say the work that has been done is known as the potential difference. Did you understand what is electric potential and electric to understand electric potential, you need to have electric potential difference, you need to understand electric potential. So electric potential is what? We have understood that the amount of work you require in order to bring 1 coulomb of charge to a higher charged body that is against the electric field, because it has to be opposite. The amount, the direction in which you are doing the applying the force in order to do the work is opposite to the force that is obstructing you. Because something, when we can say that you are doing some work, obviously when a task has been allotted to you, something that is opposing, then you are able to do the work, okay, you are able to move. So when you are able to move this unit charged particle, that means you are doing some work. And when we do this work against a single unit positive charge or 1 coulomb of charge, we say this as potential difference. Understood? Whenever potential difference means, definitely from the word difference we can understand we need at least 2 points in order to explain what is potential difference. So this is what something we have it has been shown. Okay, so it's very easy. So we know now, that means whenever, so the unit of VB is what? It will come in volts, and this unit will also come in volts. So definitely if we subtract two physical quantities with the same unit, that is volts, definitely we will get volts. So potential and potential difference, both of them, the measurement has what? Volts. Okay. Now to understand, or you can say to measure this electric potential difference, that means when we have an electrical circuit and we want to find out what is the potential difference from this point to this point, what we will do is we will attach the voltmeter in parallel. Is it there? Yeah, it's there. So it is always, first of all, this is voltmeter. Let me introduce to this. This is voltmeter. This is an apparatus which measures voltage. Okay, or you can say voltage, or you can say the potential difference. It measures the potential difference. This is the voltmeter, and it is always connected in parallel. It is always connected in what? It is always connected in parallel. Okay. Now why it is in parallel? First of all, you have to understand this point. Now if voltmeter is what? Potential difference, you are measuring amount of work, how much done. Now you yourself is becoming the part of that job. That means you are just adding jobs, right? You are not measuring jobs. So for that reason, just think in this way, we are applying it to parallelly to the circuit. Okay, there's another concept that will be covering, that is resistance. Okay, so first of all, first of all, I'll just tell you again once again. So the apparatus that is to measure this potential difference is voltmeter. This is clear. Next, we measure, when we try to connect this voltmeter into this electrical circuit, what we are going to do is we will be connected it in parallelly. Why we will connect it parallelly? We want to connect it parallelly so that that voltmeter again doesn't add the jobs. Like if it is coming in between the series, then the electrons have to flow through them also. That means that means I'm not able to measure the work, because I myself became the work, or I myself became the overhead for the flow of electrons. So I will be connecting in parallel so that I can measure how much amount of work will be done from this point to this point. So this is how we can measure the electric potential difference. Okay. And one more thing, yes, voltmeter, this will have low resistance. Why they will have low resistance? If voltmeter, my mistake. Voltmeter says I won't be the part of the job, right? Now, whenever you try to, I'll just show you in the next slide how are you connecting it. Let's say this is a potential, you can say the voltmeter, right? Now, if this voltmeter, now electrons will flow in this direction, right? The electrons will flow in this direction, right or wrong? Yeah. Now, when these electrons will flow, now they will have two paths. Right, they will have two paths. Now you may ask, ma'am, then how will it measure? Yeah, definitely. So if voltmeter says I will create an obstruction for the flow of electrons, I will become an obstacle for the flow of electrons such that the electrons don't come only to me. So then that means if it is high resistance, high resistance means high obstruction is there, then will the electrons will move through? No. So all the electrons, not all, definitely some will get jammed. So other electrons will try to move in this and the circuit will be complete, right? And the circuit will be complete. So since few of the electrons are moving through the voltmeter, so we can say it consume like less current. Current we will see what to be done with this term, but little bit amount of electrons are moving through them. For that reason you can say the whole lot of the whole 100% electrons are not moving to the bulb. Okay, few of them, very rare, because the path is high resistance, means it will pose obstacle to the flow of electrons. Now the electrons that did not travel to this path, and that makes the circuit complete. So as a result, voltmeter will measure the potential difference between them with the condition that it is connected parallelly and it has high resistance. Okay, next we will come to the numericals. Electric potential difference. How much work is done in moving a charge of 2 coulomb across 2 points having potential difference as 12 volt. Okay, now let's see. That means we have V as 12 volt and charge as 2 coulomb. Now we know that V is equal to W by Q. Now what they are asking? They are asking how much amount of work is done in moving a charge. So that means we need to find out W. So if we want to find out W, that means we have to find the product of volt and charge. So what is a volt? 12, it is a very straightforward question, and 2, that means it's 24 joule. Now why did I write here 24 joule? Because we know all of them are in SI unit, volt, coulomb. So whenever we are saying volt, coulomb, that means definitely volt into coulomb is joule. Okay, so this is very easy sum, right? Okay, next numerical. How much energy is given to each coulomb of charge passing through a 6 volt battery? Now this is a question we need to understand that when I am talking about the word energy, we know energy means capacity to do work. So if we know what is the capacity to do work, that means we know the energy. So how much energy is given to each coulomb of charge passing through a 6 volt battery? So we know the volt. So volt is how much? 6 volts. Charge means Q is equal to what? 1 coulomb. So you need to find out W again. So we know that work done is a product of voltage and charge. So voltage is how much? 6. Charge is 1. That means 6 joules. Remember one thing, that 1 volt is equal to 1 joule by 1 coulomb. So 1 joule is a product of 1 volt into 1 coulomb. So if, let's say, if I am saying 5 volt per coulomb, that means this part we can say as what? Sorry, this is not a product. So 1 volt and 1 coulomb, so it will become 1 joule. So is it clear? So if I say 5 joules, that means 5 volts coulomb. Understood? So this is how we try to say. Okay, so we can come to the next question. 500 joules of work is done in transferring 40 coulombs of charge from one terminal of a battery to the other. So how much amount of work you are doing in moving and transferring this charge? 40 coulombs of charge are transferred from one terminal of a battery to the other. What is the battery voltage? This is also easy because they have given you W this time, that is 500 joules. Okay, and charge they have given as 40 coulombs. Fine. So they are asking what is the battery voltage, that means V, that means W by Q. So W is how much? 500 and charge is how much? 40. So 0 0 gets cancelled. So it's 12.5 volt. Why did I write volt? Because after all it was joule and it was coulomb. So 1 joule by 1 coulomb means, what I am trying to say is 25 joules, 25 by 2, and this is what is written. So if I just segregate 25 by 2 into 1 joule and 1 coulomb, so that means we can say this one as volt, right? This is something that I have written here. Okay, so so that means the battery voltage is 12.5. Okay, the next question. 3 2V cells, that means voltages 2V cells are connected in series. That means the battery is like this. Like this, fine. So 2 volt, 2 volt, 2 volt. Okay, connected in series as a battery in circuit. What is the potential difference at the terminals of the battery? Okay, what is the potential at the terminal of the battery? Okay, that means definitely the amount of work done, but maybe what is the potential difference of the battery? No, actually the terminals of the battery, as in, you know, this is in cells, right? Cells make up the battery. So I have just done a drawing a bit wrong. This is the whole thing and this is my battery. Fine. So it's pretty easy. That means if we have 2 voltage, 2 voltage, 2 voltage, that means the amount of work to do till this point is 2 volt. Again this point 2 volt, 2 volt. That means total it will be 2 plus 2 plus 2. That means total 6 volt. Okay. Next question. How many joules of electrical energy does 1 coulomb charge gain on passing through one cell? Okay. So if I am passing through one cell, if I am passing through one cell, that means I am passing through just a single 2 voltage cell. Now what they are asking, how many joules, that means they are asking how much amount of work done. So we know work done is equal to product of voltage and charge. So voltage is how much? 2, and charge is how much? 1 coulomb. So it will be 2 joules. So 2 joules of work will be done in moving 1 coulomb of charge in moving through the 2V volt, means 2V potential difference. Now next comes here, what if, so this is B1. Now next will come with B2, that is all the 3 cells. So total, again same story. So W by Q, so we have to find out W is equal to VQ. Now what is my V? V is, okay, now here V is total 6 volt. So we will do here 6, and coulomb same, 1 only. So it will be 6 joules. Now why they have asked you this question? Understand. If that means the total amount of voltage that they will give you, the total amount of voltage that they will give you for pass 1 coulomb of charge, that means voltage means that much amount of joules will be work done, means that much amount of work has been done. And if you are passing through all the 3 cells, that is where each cell is having 2 volts as a potential, that means again the same thing, because here one thing that has been kept constant, that is 1 coulomb of charge. Okay, since 1 coulomb of charge you are passing through them, that means when we are talking, when the scenario or when the situation is as such that you are playing with 1 coulomb of charge, that means in that particular scenario voltage and work done is the same, right? Because it's explained also before that when we are talking about the volt, that means we are considering that the charge is 1 coulomb is fixed and voltage and the joules become the same. Okay. Thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel Vigyan Jyoti, hit the like button and share it with your dear and near ones. And yes, please don't forget to comment, because your feedback does matter.